Hi guys. Sorry, I had to update my Discord client.
No worries. Thanks for being on today. Appreciate you being here. So I think we're about 3 minutes in, so we probably can get started. We have a few people here.
Nice.
Yep.
Hi everyone. Good to meet you all. Shall I share my screen?
Yeah, definitely share your screen. And then also, just if anyone's coming to the event for the first time, I just wanted to welcome you. And this is our DidHack breakout session with SpruceID on DidKit. So I'm going to go ahead and hand it over to Charles, who is going to share his screen and take us on.
Yes. Sorry, I have to close Discord to give it the permissions again. Sorry. We'll be right back.
No worries. And in the meantime, if anybody has any questions about the event, where to find things, if you're completely lost and here for the first time, just let us know. Also, if you have any questions, the top right, that's the chat for the main stage. You'll see the little chat box. And then also, we have questions that can be asked from the stage. You can request to speak.
Hi guys. Sorry again. I had to quit Discord to give permissions. But yeah. So, can everyone see my screen?
Yes.
Okay. So just going to do a very quick intro to SSI and DIDKit, and then I'll walk through some command line operations using DIDKit. Yeah. So I know that you guys have probably had brief introductions to verifiable credentials and DIDs already, but I'll probably recover some of that ground, but should be quick. Yeah. So today, the way that identity on the internet works, usually you have an email address on a particular email provider, and you have a password for that email address. And your email plus your password is your identity. If you sign in with Google on to a different service like Netflix, then Google is the gatekeeper of your identity on the Netflix service. If Google decides to, for some reason, delete your identity or misrepresent that identity, then they can do so without detection. There's nothing that you could do to alleviate that because they control the infrastructure that is built around your identity on the internet. Yeah, so Alice at example.com is Alice according to example.com, and example.com knows that you're Alice when you sign in because you supply the password. If you have an application and someone signs in as Alice at example.com, you know that they're Alice if they can provide the password, or if example.com tells you that this is Alice, like signing in with Google, for example.
Charles, I'm sorry to interrupt, but we're seeing a blank screen. Are you demoing something at the moment?
Oh, I'm sorry.
We're seeing your browser. We're just not seeing, I don't think we're seeing what you're demoing though.
Okay, I'll just share my entire screen. Is that better?
Yeah, it says root of authority.
Yep.
Yeah, that's it.
Sorry about that. Yeah, so today on the internet, this is how identity is mediated. We use third-party identity providers as trusted intermediaries who promise that they know who we are. For third-party services who need to perform some level of identity verification, like KYC or, signing into Netflix, stuff like that. DIDs are a little bit different way of doing things to do identity on the internet. DIDs are a particular type of URI, which URL is one type. And a DID is a open specification which allows a wide variety of ways to define the link between an identifier and the public keys that are associated with that identifier. So that if someone signs something using one of the private keys for those public keys, then anyone can verify that this identifier was the one that signed this information. And this sounds kind of silly, but it's very important because there's no party that stands between management of the identifier and proving that you control the identifier. So in this case, before we had, Alice at example.com, now we have a did method, did example, which is obviously not real, Alice. And for example, one did method could define itself by saying, okay, anything that follows did and then BTC, anything that follows that has to be a Bitcoin address, and then the associated public key is the public key of that Bitcoin address. And then there's no way for anyone to prevent you from finding out what the public key is, given that DID. And then there's no way to prevent anyone from verifying that this DID signed some piece of information. So in this way, you can verify that someone who has a particular identifier, if it's a DID, actually is that identity, that person, that device, that smart card, whatever holds the private key associated with this DID. And this is very powerful because using DIDs, we can verify any kind of information and we can know that it came from a particular source and we can identify that source and we can refer to it in other documents. So it's like URLs. URLs resolve to some data, usually it's a website, some HTML and some JavaScript. A DID resolves to what's called a DID document, which is essentially a list of public keys. If someone signs using one of the private keys associated with that public key, you know that they are that DID. So if I say, how do I know this is Alice? If Alice shows me a message and she shows me a signature made over that message, and I look up her DID and I get the public key and I verify the signature that she made, then I know it's Alice. Easy. And I didn't have to ask Google. I didn't have to ask example.com. I didn't have to ask anyone. Some DID methods are slightly more complicated, and there is indeed a DID method which is defined using web addresses. So DID web will use, www.google.com. But for the most part, DIDs are fully decentralized, or at least as decentralized as is practicable. And this is very useful for upholding trust, or not just upholding trust, removing trust entirely from the equation. We no longer have to trust Google or example.com to promise, that someone is who they say they are. So what? Wow, crazy words. Verifiable credentials are how we actually state these claims. So if we have a user Alice and we want to know something about them, we know that, we know that they control did example Alice, but that's not very important. We don't know anything about this identifier otherwise. How can we know some things about Alice in this case? We can get a signed statement from someone else that we do trust to know about whatever it is we're thinking about. And they can tell us explicitly that, Alice can access this service, for example. The easiest case to think about in the real world is something like, driver's licenses. If you get pulled over on the road, an officer will ask to see if you have a driver's license. They're effectively trying to know that the state of whatever state you're in has claimed that you're allowed to drive, and that's all they need to know. In this case, the state would have a well-known DID that everyone knows is the state of, Idaho or somewhere. And then they would look up the DID, get the public key, verify the signature on this credential that says Alice can drive, and then Alice just has to prove that she controls the DID, so she also signs something. And then everyone in the interaction can prove independently that the state of California says Alice can drive. This is Alice right here. She's allowed to drive. Yeah. Are there any questions at this stage? Because I know I'm retreading ground that's already been covered.
I think it's a great explanation on decentralized identifiers. You've probably done maybe one of the best jobs I've heard explaining it. But I'll check in with the audience. Anybody have any questions for Charles? Anything that he's gone through up to this point? Somebody is typing, so I think there's a question that's coming. So Alyssa's asking, what's your favorite DID method?
That's a hard question. There's up to when I said that DIDs can really span a wide variety of methods, there is probably over 200 at this point. Yeah, it's I couldn't choose. There's seriously too many. I like DIDPKH. It's very simple. Any blockchain account can be mapped to a DID document using DIDPKH. It's a very nice, clean, simple method which doesn't require any network access. A lot of DID methods are essentially reducible to generating a DID document on the spot because the DID contains all the information you need. So with our previous example of a Bitcoin account, because you can never change the keys associated with a Bitcoin account, you can't ever change that public key associated with the DID, but it also means, given the DID, you know everything about the DID document that you need to build the DID document itself, which is super useful if you're a developer. You don't need to set up any infrastructure or anything like that. You can just get going, which is really nice. Other DID methods are a bit more complicated, and you can update your public keys. But once you get into that kind of those kind of waters, thank you for adding the link, Cypher Queen, to the DID method registry. Once you get into the waters of being able to update your DID document, things get very complicated. Then different systems have different means of kind of distributing trust and all this kind of stuff. But good methods, I would say, are So Ceramic has a did method. It's quite good. There is a did method called SideTree, which is quite good. That's considered a generally good option. Many blockchain ecosystems will have their own kind of smart contract based did methods. So if you like a particular ecosystem, there's probably someone in that space that's providing a did method. Yeah, and there's 169 did methods in the registry right now. Thank you again, Cypher Queen. Yeah, so what's your favorite did method? That's a good question. I'd have to do some research, honestly. Yeah. I imagine there's no other questions about DIDs. It's
I see any other questions coming in right now. So yeah, we're good to keep going.
all right. So VCs. When you want to know something about someone, it's not just important what you want to know. It's also important who you think is trustworthy in giving that opinion, because essentially everything's an opinion, but if enough people back it up and there's a lot of proof, then it becomes fact. Or if you have some authority that you trust, then you take this opinion as fact. So in the case of, are you allowed to drive a car? Are you qualified to drive a car? The state that administers the roads, or whatever authority that is, where you live, they're the ones who everyone trusts to say, okay, this person is allowed to drive. So in that case, you would just have the DID of that authority, and then you would take them as the authority in the context in which you are operating. In this case, driving a car. In other cases, it might be, using Netflix. If you sign in with Google, then Google telling Netflix using OAuth 2 or something that you completed a sign-in flow is, if you squint, kind of a credential, except that the identifier that they're talking about is controlled by them as well. So credentials and DIDs pull apart the identifier and the statement about the identifier so that you can remain in control of your identifier, and then you can still enable other parties to make statements about you, because that's useful in the real world. In the real world, if I say that I can drive a car, the cops aren't going to trust that. If I tell Netflix that, yes, I am indeed myself, they're not going to trust me that, I'm definitely a Gmail user. They're going to trust Google about that, but not me. So signing in with Google on Netflix in this view would look more like Google giving you a verifiable credential that says this person has, this DID has the email address, charles.cunningham@SpruceID or something. And then Netflix could verify that credential and say, okay, I believe you because I trust Google and Google says this. And there you go. So VCs are how DIDs can talk about each other. Every trust relationship becomes explicit by having a signed and verifiable piece of data behind it that says, here you go. Here's my opinion. Here's who I am. You can trust me, and if you trust me, then it's a fact. And you can have different degrees of trust if you want, but that's, generally up to whatever system you're building. Yeah. So VCs express assertions about things. VCs use DIDs. VCs act as verifiable assertions. And that about covers it for just talking about DIDs and VCs in concept. That was a bit of a vague explanation, sorry. But I'm sure you guys, I don't want to just show you the specs on screen because that's not going to be very fun. Yeah. Are there any questions at this stage before I dive into DIDKit?
I don't see any questions coming through, but I just want to say that was a great explanation. Thanks a lot. It also doesn't hurt for people to hear things in different ways from different voices in terms of learning. So awesome. Thanks.
Cool. And now I am just going to go through some of the functionalities of DIDKit and what it is. So at Spruce, we have been working for a while to build a lot of tools related to the self-sovereign identity ecosystem. And most of these exist inside our SSI toolkit. This is a collection of software packages written in Rust, which embody many of the specifications found in the SSI ecosystem. So we have a package for DIDs, we have a package for all kinds of, JSON Web crypto stuff, JWKs, JWS, JSON Web tokens. We have crates for integrating with a variety of different DID methods. And we also do some other specifications like UCANs. We've got VCs, we've got ZCAP-LD, which is related to VCs, but not quite. Yeah, and all of these are available in Rust, but with DIDKit, we package them into packages for different languages. So we've actually got bindings for C, Flutter, Android, iOS, Java, TypeScript, both Node and web, using WebAssembly, and also the CLI, command line, and HTTP. This HTTP server is just an implementation of a kind of a standardized VC HTTP API, but we don't have to get too far into that. Yeah. But DIDKit allows us to generate keys, but it's not a wallet. It just allows us to generate the keys. It allows us to generate credentials in the correct format and sign those credentials using the keys we generated. It allows us to associate a key with a DID when we sign these credentials, and many other things. But first, we're just going to go through some of the stuff we can do on the CLI. We can do almost all of this functionality in all the languages I mentioned. TypeScript is especially useful, but the API, because we use WASM, isn't the best. It requires a lot of stringifying, so I'm just going to use the command line right now. Yeah. So we can do. Oops, that's not the right one. So we can easily generate a key pair here. So this is just a private key expressed as a JSON web key, and we can write it into a file very easily. And then similarly, we can take that key and we can set it to, we can express it as a DID using the DIDKey method, which just takes any public key you have and turns it directly into a DID. So one key, one DID. That simple. So in the first, big mode. In the first command, we generate a key. using generate ed25549 key. And then the second command, we use the key to did function using the DIDKit method to turn it into this DID. So now we have a key and we have a did. If we want to issue a credential, for example, first we need a bunch of JSON which corresponds to the statement that we want to make. So we can get, I'm just going to copy this. So here we've got a credential. This isn't going to work because the ID here is not set correctly. It's a verifiable credential. It has a date and it has a credential subject. Now this says that ID here, just the environment variable cred did, is saying about the ID here, subject did, you know, something. Right here it doesn't really say anything, but if we copy the whole thing, date. What do you mean wrong? Okay, well, I misrepresented the date there, but gonna make it today. So here, this just says, you know, this is just an example credential about no one really. But when this gets signed, someone else can come along and verify it independently of the issuer. You could take this to a totally different machine and run this command, and it would tell you that, okay, this was definitely signed by the issuer. And it's important to know that that's all it tells you. It doesn't tell you that the issuer is some authority or anything like that. It only tells you that did A said something about did B. This is useful when you already know who did A is and why you should trust them. And usually when you develop an application, that is something you already know. Most of the time we already trust authorities on the internet with information, but this makes it very explicit, and it means that our trust happens in the open. Does DIDKit use a blockchain to store the DID document? So DIDKit does not use any blockchain infrastructure to store DID documents. There are DID methods that do that. There's an Ethereum-based DID method called DIDEther. I'll just write that in the chat, which does do that. But we ourselves don't. I guess we'd say we don't align ourselves directly with blockchain ecosystems to that extent where we would say you must use a blockchain to manage your DID document. The DID methods we do support don't actually rely on blockchains themselves. But in principle, any DID method can say that they do want to use a blockchain to store a DID document or to store the information required to construct a DID document. Yes, you can actually create your own DIDKit, your own DID method. It's totally totally free. All you have to do is write a definition and submit it to the DID method registry. It's actually easier than you would think. You just have to be mindful of choosing a name which is not, not too short. You don't want to step on anyone's toes in terms of choosing a method name which might be more closely associated with their ecosystem. So if you're going to create a DID method, it would be a bad idea to say it's called DID Bitcoin if you're not going to base it directly on Bitcoin, for example, or if you're not closely associated with that community. But otherwise, all you have to do is have a well-defined way of resolving a DID. For example, this is the draft for DIDPKH. And it simply defines resolving a DID according to certain rules, but that's all you have to do. You just need a way for it to get a DID document if you give it a DID. That's essentially the only rule you need to have a DID method. Of course, you also need to have a security considerations sections and stuff like that, because that's what DIDs are targeted at. They should be secure. Only the controller of the DID should be able to update the DID, for example. But yeah. Another question. Can DIDKit be used to learn and not incur? Yes. So Cypher Queen asked, can DIDKit be used to learn and not incur expenses from paying for ETH? Yes, it can. I would recommend, until you're going to launch a full product, to not use any DID methods that use on-chain resources for that, for this reason. It will cost you some money to spin up DIDs that use on-chain DID methods. But one of the big benefits of using DIDs is that the user's DID is like management of a user's identifier is no longer the problem of the application developer. The user can bring their own DID to your platform, and then you can use the DID that they give you as long as they prove that they control it by signing something. So in that sense, DIDKit is a great tool for building DIDs that represent your services, and for verifying the DIDs of users that bring their DIDs to the service, and also for users to build their own DIDs. But while learning, I would strongly recommend just use a straightforward DID method like DIDKey, DIDPKH. That will get you 98% of the way to any practical use case that you need. More complicated DID methods are usually for fairly application-specific things. Not often does someone actually need key rotation built into their application, for example. A user who uses a wallet will need a way to change their DID document, but as a platform developer, you will not often have to actually do that yourself, which is a really good separation of concerns. So can we use DIDKit to build new DID methods from scratch? Yes, you can. So what you would need to do, well, first what you would need to do is define your DID method well, which just means kind of plan out how it's going to work and write a method specification. This is a really good example, so I'm going to drop it in the chat. this is one that we worked on at Spruce, DIDKit. It maps any blockchain identifier, any blockchain account to a DID document, because 100% of the time, well, okay, 99.5% of the time, a blockchain account, the address is linked directly to one public key, and that never changes. So DIDKit kind of encapsulates that whole concept into a single DID method, so that there doesn't need to be 100 million different, DID methods that all sort of do the same thing, but just have different ways of doing it. The second thing you would have to do after you define your DID method, writing the spec, would be to implement it. And that just means building some convenient APIs that let users, interact with a DID method that they have. In particular, we have this, Rust crate DIDs, SSI DIDs. I shouldn't just show you guys pages full of code. But this does things like, define a DID document in code. So if you resolve a DID in Rust using DIDKit, you'll get back one of these structs that says, this is the ID, also known as controller, all the same stuff you're going to find in a DID document. And then you can interact with it programmatically. So what you would do is you would implement this trait that we have defined called DID resolver. Where is it? DID resolver. So this is a trait we've defined, which essentially all DID methods have to do this, and all they have to do is resolve. Very straightforward. You give it a DID, which is just a string. You give it some metadata, which is defined by the DID method spec, the resolution spec. And then it gives you back a document if it can find it, and it gives you back some metadata if it can find the document, and it gives you back some resolution metadata, which informs you about the process that took place to retrieve the document. So at Spruce, when we implement a DID method, we just implement this trait for a new, in a new way to build a new DID method. I will show a very quick example for DID key is a better example. So the DID key method I used earlier, this is very verbose, but here you can see we define DID key. Again, DID key is so simple that it doesn't even need to contain anything. It's just a completely empty signal. We implement resolver, and all we do is check that it starts with a key, and then we decode the key from base 64, and then based on a certain code at the start of the key, for example, where is it? Sorry for my color scheme. These first 4 or 5 characters, when decoded from base 64, will identify this as being a key of a particular type. In this case, ED25519. And that's it. That's how DID key works. It'll just give you back a DID document that contains only that public key. Yeah, so defining a DID method is a really nice exercise to kind of figure out how they work. And you'll kind of realize that some of them are deceptively simple and some of them are very complicated. Because some use cases get increasingly complicated. Cypher Queen asks, if my use case is IoT, do you have any advice? Yes. So IoT devices, typically you don't want to use a DID method that relies on a lot of network calls. So for example, if you have to check an Ethereum smart contract to get the current DID document of a DID, then that is going to make your IoT network much less practical. My advice would be to use, if possible, DID methods for your. So each of your device would have a DID associated with it. And I would recommend that each of those devices uses a DID method like DIDKey, for example, where that DID never changes, so that you never have to do a network request to look up the DID document for that DID. There are DID methods targeted at IoT use cases that do allow you to update them. And they are some of the more complicated ones because they rely on properties like eventual consistency and stuff like that. But a really interesting one. So if someone said, do I have a favorite DID method? I sort of do. It should be in here somewhere. So DID carry, where do I get the, it's me. So this DID method is a very interesting DID method. It's got a lot of really interesting features. It is fairly in-depth. This is probably one of the more complicated DID methods, but if your use case is IoT, this is one of the primary focuses of this DID method.
Charles, I think your screen is being blocked by the Discord.
Oh,
if you're
sorry.
Show us the,
yes.
Yeah, perfect. Thanks.
So the DID carry method is a particularly nice DID method in terms of its completeness and stuff like that. But it has a lot of edges to it that have to be considered in adoption. You need to stand up some of your own infrastructure in order to make DID carry practical. And there's essentially with DID methods, there's a big trade-off between how many features you get and how much infrastructure you need to manage yourself, and how much you need to trust people who've already deployed their own infrastructure. So I can answer also Peter's question about DIDKey compared to other DID methods. I'll draw a terrible diagram here to illustrate. But we've got three properties, kind of. We've got trust. We've got effort / infrastructure. So how much work do you have to do to actually make these DIDs function? And we've got features. So if you don't, you can have essentially 2 out of 3 of these. At most 2, but not 3. If you don't care about trusting an Ethereum node provider, for example, then you can get all the features of DIDs that run on the Ethereum blockchain. So generally they're pretty secure. They can be updated, so you can change the keys associated with your DID. They can fulfill all the optional fancy features that DID methods can have. If you don't care about trusting an Ethereum node provider, then you can just pretend that that's fine, which in most cases it is. And you can get all the features you want as long as you trust someone. If you don't want to trust them, then you have to run your own Ethereum node and only ask that node to give you back results. So it removes trust from the equation, but you have to run your own infrastructure. DIDKey because there's no infrastructure involved, there's also no trust involved. Every DID key resolves to the same DID document forever. There's no way to change that. No one can stop you from getting the DID document if you have the DID. There's nothing standing between you and the DID document. With Kerry, for example, you need to run your own infrastructure because there is no public infrastructure component to enable you to resolve a DID if you don't know where to look, kind of. So that's and this is a common theme in kind of IoT use cases. It's often not about, going to some well-known HTTP address. It's more about, you have one device and another device. You just need to know that the message from the second device was definitely issued by that device because it has access to a key. Does that answer your question, Cypher Queen? There's a lot to think about when it comes to IoT because it's such a particular use case. But in general, I would recommend simpler DID methods, DID key in particular, if it's possible. Sweet. And yeah, Peter, I hope that answered your question as well. DID key is essentially the simplest DID method you can think of. And in that aspect, it's actually probably the most useful right now, because everyone agrees on how it works. And there's nothing that can go wrong, essentially. If you have a resolver for DID key, you don't need to worry about a network outage. You don't need to worry about, some HTTP service not being available. There's much less to worry about when you use DID key. And the same thing is true of DID PKH. Yeah, I sort of got off track there. Do we have any questions? Otherwise, I might go through more of an overview about SSI and DIDKit.
I actually did have a question. You mentioned DID web not being completely decentralized. Can you say a few more things about that? What you mean by that?
Yeah, certainly. So DID web is a very well written spec. There's nothing wrong with it. It's just that so it is defined essentially as using a web address, like HTTP address, as the identifier. So literally like didweb example.com. How it works is that your resolver would browse, essentially use the internet to browse directly to this web address, and then add an extra, it would add an extra well-known to the end. So it would essentially turn this into, instead of did method web, it would say did method / dot well known / did.json. And this isn't going to work, but I'd be very surprised if it did. No, it does not. But essentially, if you perform a GET request at the given HTTP address, then it will return back a DID document in its full form. So this is decentralized in the sense that, you can go and set up your own web server at this particular address, but it's centralized in the sense that the servers that designate these web addresses are controlled by a limited set of authorities in the world. the name registrars on the internet are essentially trustworthy, but in this case, to resolve this identifier, you do have to trust them that they're giving you back the correct IP address to then resolve this document from. Other DID methods don't have that kind of implicit trust assumption built in. So DIDWeb is as decentralized as the internet, and that is usually good, but is not guaranteed to always be perfectly decentralized, I guess is what I meant by that. Does that answer that question?
Yes, it does. Thank you very much. I will point out that I'm just keeping track of the time. We do have just a few minutes left. Did you have anything else in closing that you wanted to say about DIDKit or anything else?
Sure. There is a I mean, I've done a terrible job of doing a code walkthrough, but there is some good documentation here about getting started with DIDKit. I would say it's the most fully featured Rust API for dealing with credentials and all kinds of SSI specifications. In other languages, it is available. Particularly in TypeScript, we use it quite a bit. Also at Android and iOS, it's quite useful. Yeah, I think that anyone who's getting started with DIDs and VCs would become best acquainted by quickly making a DID, issuing a credential, and then verifying it on a separate machine where they didn't create the DID. And then they can see that regardless of where a credential was created, it can always be verified because the DID always leads back to the same DID document. And I think that's the core benefit of using DIDs and VCs, is that you don't have to depend anymore on, you know, some identity provider service that you have running in a Docker container that verifies all the JSON Web Tokens and makes sure that, you know, they were all issued by some other service that you have. Now you can just have a DID in a container somewhere. It can issue a credential, and then another container can verify that credential without having to have any communication back to the issuer. Yeah, I think DIDs are poised to become a core piece of infrastructure for the internet. They're already becoming adopted pretty widely. And they're once you start using them, you see how useful they are. Because identity is a really omnipresent topic within programming and computer science, especially when you're dealing with networks. You always want to know who someone is, and you always want to know things about that person and who said those things. Yeah.
Awesome. That was so interesting and informative, Charles. I want to thank you very much for joining us here today and sharing all your knowledge. And I also do want to point out that we are going to have another session right after this, which is going to be Aviary Tech. So that's going to be Brian, one of our co-organizers. It's going to be on the stage. I do have to stop and restart the stage so that it shows his event, but it's going to be in the same location. So if you need a bio break or get another cup of coffee, go ahead and just meet us back here in just a couple minutes.
Cool. Thanks, everyone. Thanks for attending. And thank you for the questions.
All right. Thanks so much, Charles. Oh, and also there is a chat for SpruceID if anybody wants to ask specific questions to Charles. Async. So